Okay, so in this problem, we're looking at this differential equation, and we're asked to find equilibrium solutions of the equation. So to find those, we need to set y prime equals 0. So when we do so, we'll have to solve 0 equals 4y times y over 3 minus 1. We can immediately see that this gives us two solutions, y equals 0 and y equals 3. So these are our equilibrium solutions. So let's sketch a set of axes here. So we have an equilibrium solution at 3 and one at 0 that are important. So now let's think about what's happening to the solutions in between these regions. So when y is greater than 3, this y out front will be positive. This fraction will be bigger than 1, so that means this term will be positive. So overall y prime is greater than 0. So we can sort of draw an arrow in here to indicate that y is increasing. When 0 is less than y is less than 3, we're in this middle region here. Y is still positive, but now this fraction is less than 1. That means this term becomes negative. So overall, y prime is less than 0. So y is decreasing. And lastly, when y is less than 0, we see that now this fraction is still less than 1, so this term is still negative, but now this y out front is negative as well. So overall we get two negatives, which means y prime is positive. So we have something like this. So from this we can conclude that y equals 0 is stable, and y equals 3 is unstable. The reason for this being that from these arrows we can see that a solution which starts in this region here will move away from 3 and towards 0. A solution that starts down here will move up towards 0. And a solution which starts above 3 will move away from it. So all the solutions that start near 3 move away from 3. And all the solutions down here move towards 0. So that's why 0 is stable. The solutions are attracted towards it, whereas the solutions move away from 3, so it's unstable. Now in part B, we're asked what happens to what the solution y depending on the initial condition. So we can reason as follows. If y of 0, which is what we're calling C, is less than 3, then the solution will approach y equals 0 because of this picture here. So that means the limit as t goes to infinity, y of t is going to be equal to 0. If y of 0 is greater than 3, then the solution grows without bound. Right, so from this picture we can see it just keeps going up. It never hits another equilibrium solution, so it's just going to continue increasing. And that means that the limit as t goes to infinity, y of t is going to be equal to infinity. Then the last case we have to consider is what if y of 0 is equal to 3? Well then, solution stays at 3 forever because we started on an equilibrium solution, so we never move. That means that the limit as t goes to infinity, y of t is equal to 3. So we have these three possible cases. If we start anywhere below 3, we'll approach 0. If we start on 3, then we stay there. If we start above 3, then we just go off towards infinity.